Okay, we're starting a new module, and in this module, though, we do sort of pick up where we've been before. We have solved equations, either using the addition property or the multiplication property, and we have in separate exercises simplified algebraic expressions. So let's take just a minute. We're going to use both of these properties. We are going to solve equations, but I want to remind you that an expression, let me make that a slightly better circle. An expression does not have an equal sign. It is a sum or difference of terms. It can be simplified. It cannot be solved. An equation has an equal sign. It has an expression on the left and an expression on the right. So over here you see an expression, an equal sign, and an expression, an equal sign, and an expression. You can solve an equation. Expressions can only be simplified. Equations can be solved. As a review, now both of these come from previous lessons. The addition property of equality says you can add the same amount to both sides or subtract the same amount. The multiplication property of equality says you can multiply both sides by the same amount or divide both sides by the same amount. Something else that I've placed on this page is a review of the rules for integers. So if you want to, you could pause this video and copy those down again into your notes. Addition, subtraction, multiplication, and division with your signs. Let's go ahead, solve equations. We'll be using both of our properties. I will probably give myself a little extra workspace in these. All right, the first one I'm going to solve, I think I'll use blue ink this time. I have x minus 6 is equal to negative 1 plus 3. Now, something we have not had to do before is simplify either the left expression or the right expression. That's something that's a little new. On the left, can you simplify? No, x minus 6 are not like terms. On the right, can you simplify? Yes, those are constants. You have a negative 1 plus a positive 3, negative plus a positive. We subtract, keeping the sign of the larger. That's 2. So I have x minus 6 is equal to 2. Now, I did not change the value, so I didn't have to do something to both sides. All I did was simplify. It's like cleaning house. I did it with one side. Now, do I have x's on both sides? No, the x is over here. That's very good. I want it by itself. That means I need to get rid of a subtracted 6. So I'm going to have x minus 6. The inverse is plus 6. Equal sign. 2, do the same thing, plus 6. Minus 6 plus 6, that becomes 0, so I just have x is equal to 2 plus 6 is 8. I've solved the equation. Something that was new was before I started worrying about which side something was on, I simplified. Couldn't simplify the left, but I could on the right. All right? Let's look at our second equation to solve. I have negative 22 plus 3 is equal to m minus 10. Put my barrier. My first step is can I simplify either expression, the left or the right expression? Yes, I can simplify the left expression. It's a negative 22 and a positive 3, one negative, one positive, subtract for 19, keep the sign of the dominant, which is negative, and that equals m minus 10. Do I have letter m, the variable, on both sides? No. So let's focus on the side where you do see the m and see what you want to get rid of. You want to get rid of the minus 10. Now, I'm going to do something a little different, and I'm going to start doing it now. Rather than rewrite this whole thing, I know that this is minus 10 and I would like to add 10 to it. And I put it underneath. It's just a shorthand way to do this. But if I put it underneath on this side, I have to put it underneath on this side. Now, these are like terms. I'm going to combine them using my addition rules. I have a negative 19 and a positive 10. Subtract, keeping the sign of the larger. That's negative 9. The m comes down, negative 10, positive 10, those canceled out. So what was different was I didn't write negative 19 plus 10 equals m minus 10 plus 10. I didn't write it that way. I just put the plus 10 underneath, and it's a nice shorthand way to write it. Whoops, went too far. Number 3. All right, I have 2w minus 14w equals 84. Step number 1. There's an expression on the left, there's an expression on the right. Can I simplify either one of them? And let me remind you what it means to simplify. To simplify has potentially 2 steps. Distributive property, to remove parentheses, and combine like terms. So I look for those 2 steps on the left expression, and then I look for those 2 steps on the right expression. On the left, no distributive property, but I do have like terms. Positive 2w, negative 14w. Use the addition rules. That's going to give me negative 12w is equal to 84. Do I have w's on both sides? No, I just have a w over here. I need to get rid of this negative 12 times w. What's the inverse of that? The inverse of multiplication is division. So I will divide by negative 12, divide by negative 12. Negative 12 divided by negative 12 is implied 1w is equal to positive divided by negative is negative, and that is negative 7. So I used my division rules. Okay. Oops. Keep moving too far and too fast. All right, next one. 42 is equal to t plus 6t. All right, my first step is to look at the left expression, look at the right expression, see if I can simplify either one. Well, there's nothing to simplify on the left expression. On the right expression, those are like terms. That's an implied 1t plus 6t gives me 7t. Now, where's the variable? It's over here. What's going on? Multiplication. What's the inverse? Division. Divide by 7. If you divide the right side by 7, you have to divide the left side by 7. That's going to give me 6 is equal to t. All right, number 5. I have 3z is equal to 12 minus 24. Can I simplify anything in the left expression? No. Can I simplify anything in the right expression? Yes. Using the addition rules, positive 12 and a negative 24. Subtract, keep the sign of the big one. That's negative 12. 3z is equal to negative 12. Now, do I have z's on both sides? No, just over here. What's going on? Implied multiplication. That means that I will divide by 3. Divide by 3. Remember, 3 is called the coefficient of the variable. That's gone. And I'm left with implied 1z is equal to negative 4. Or z is equal to negative 4. Because it was a negative divided by a positive. All right, number 6. I'm doing quite a few of these examples. If you don't need all of them, that's fine, but I'm doing lots so that you have lots to refer to. All right, here's my sixth problem. Here's the equal sign, which is the barrier. Expression on the left, expression on the right. Can you simplify either one? Well, on the left side, you don't have distributive property, but you do have like terms. They just happen to be separated. Positive 6x minus 5x gives me implied 1x plus 10 is equal to 19. Now I don't need to write that 1, so I just have x plus 10 is 19. Do I have x's on both sides? No, just over here. Well, it's not alone. What's going on? There's an added 10. What's the inverse? I hope you're thinking subtracted 10. This time I'm using my shortcut notation. I'm going to put subtract 10 underneath it and subtract 10 on the right-hand side as well. That means I need to bring down the x. Positive 10 and negative 10 combine to be 0. Positive 19 and minus 10 gives me 9. X is 9. All right, number 7. I have 2 parentheses, 4x minus 4, close parentheses, is equal to 9x. The problems are getting more and more complicated, but I really still only have a certain number of steps to do. Step number 1, and I am going to summarize these, is can you simplify the left or the right expression? Yes, I can simplify the left one. I can use the distributive property. 2 times 4x gives me 8x. 2 times negative 4 gives me negative 8. Is there anything else I can do over here to simplify? The answer is no, those are not like terms. And that's equal to 9x because there was nothing I could do over there. So simplifying is done. Now, do I have variables, x's, on both sides? Yes. We did these back in a previous unit, and you have to eliminate one of them. There is not a right or wrong choice. But I typically choose to get rid of the smaller one. And 8x is smaller. Whoops, sorry. So to get rid of a positive 8x, I'm going to subtract 8x. But if I do it on that side, I have to do it on this side. I'm using my shorthand notation of writing it underneath. That's gone. I have negative 8 is equal to, what's 9x minus 8x? Well, it's implied 1x. So negative 8 is equal to x. Problem is solved. Distributive property in the process of simplifying. Variables on both sides, took care of it. There was nothing else to do. Number 8. I have 13y is equal to 12 parentheses y plus 12. All right, this barrier is rather important, so I always write it. On the left side, there's an expression. Can you simplify it? No. On the right, there's an expression. Can you simplify it? Yes. We should be able to use the distributive property. 12 times y is 12y. 12 times 12 is 144. Copy down the 13y. After you've simplified everything on the left expression, everything on the right expression, check and see, do you have variables on both sides? Because that is, you have got to take care of that next. And you do. Going to get rid of one. When it doesn't matter which one you get rid of, I choose to get rid of the smaller one. It's a positive, so to get rid of it, I will subtract 12y. Subtract 12y. This is my shorthand notation. 13y minus 12y gives me 1y is equal to, those cancel out, 144. Y is 144. Okay, almost done here. Do just a few more. I have 22y is equal to 3 parentheses 7y minus 5. barrier. First step is always, can you simplify either expression? Well, nothing to simplify on the left, so I'll just copy it down. On the right, yes, I can use the distributive property. 3 times 7y is 21y. 3 times negative 5 is negative 15. Do I have y's on both sides? Yes. Okay. Once again, personally, I choose to get rid of the smaller one. It's a positive, so I subtract 21y. Put it underneath there. Put it under any y term that's on the other side. 22 minus 21 is implied 1y, and that's been happening to us. It won't always happen. Those cancel out, negative 15. Y is negative 15. Okay, we're on our last problem. Looks pretty complicated, but we'll see. We have negative 4 parentheses, negative 2 minus 3z, close parentheses, is equal to 13z. Barrier. Step 1 is, can you simplify the left expression or simplify the right expression? Well, you can simplify on the left using the distributive property. Negative 4 times negative 2 is positive 8. Negative 4 times negative 3z is positive 12z. Those are not like terms, that's all I can do, and that is equal to 13z. Do I have z's on both sides? Yes, I do, and I need the z just on one side. So I'm going to get rid of one of them. I'll get rid of the smaller one again. This is a positive 12z, so I'm going to subtract 12z. Subtract 12z. Bring down the 8. 12z and negative 12z cancel out. 13z minus 12z, they're nice like terms. I get a difference of 1, so 8 is z. All right. That is a lesson using both the addition and the multiplication property.